I've been waiting a long time to talk about this one. No clever intro from me, let's just jump right in. Welcome to this video on querying SQL Server. My name is Kevin Fiesel. I'm the proprietor of Catallaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In this video, we will talk about one of my favorite T-SQL operators, the apply operator. As a quick warning, I'm a big fan of the operator, so much so that I have an entire talk on the topic. The apply operator has been with us since SQL Server 2005. The way that it works is, for each row on the left-hand side, we want to... Actually, I have a better idea. Let's go to the official Catallaxy Services whiteboard in the style of a Dutch Renaissance painting. That's better. Now, let's get some data on this whiteboard. The way that the apply operator works is, for each element on the left-hand side, we want to apply a function to that record and generate 0 or more outputs. Suppose that our function checks the distance and see if it's too far of a commute for us, like we're looking for a new job. The specifics of the function don't really matter for this exercise, so let's just start with the first row. Given a distance of 30, we end up with a result of OK, meaning that it's not too far of a commute for us. Now let's look at the second row. Its distance is quite a bit further, and when we get the result, we can see that this is too far of a distance for our commute. We perform this for each record in the result set. Then, with apply, we also have the option of integrating these result sets together. This is how it works in the hypothetical world. Now let's see how apply works in database. For this demo, I'm going to build up my own simple data set rather than using a larger example from a proper database. We'll use the values operator to generate a virtual table called Tibble, which contains a column call. If I run this query as is, I'll get back 3 rows with values 1, 2, and 3, just as you'd expect. The most common way that people use apply is to perform, for each row in a parent data set, a lookup against some other table. In this case, we're going to take those values 1, 2, and 3 and see which database in SQL Server has an ID matching the column value. To do this, I'll use cross-apply and, inside parentheses, write my definition function. This function operates inline and will not suffer the performance penalty experienced data platform professionals think about when you say the word function in their presence. Assuming you do things right. What we get back is the column and the database names master, model, and tempdb. Those happen to have the database IDs 1 through 3 on every SQL Server instance. So that's the normal way of using apply, but let's shake things up a bit and dig into one of the less known but great uses of this operator. Here I have our 3 rows and I'm running a cross apply. Inside the function, we take the value of col and multiply it by 3. Running this query, we can see that multiplication worked just fine. Apply, by the way, comes in 2 flavors. So far, we've seen cross-apply, which is semantically similar to, but not quite the same as, an inner join. What this means is that cross-apply will filter out cases when a function does not produce a value, like here, where I return a value only if col is greater than 1. As a result, we get back just 2 rows rather than all 3. Outer apply is semantically similar to a left outer join, in that it will return results regardless of whether the right side has anything interesting to say. In this case, we get back 3 rows, though col x3 is null for our first value. For our next trick, I'm going to turn on actual execution plans. What we see here is the typical shape for apply operations, a nested loops join. Usually, the best performing outcome when running an apply operation is a nested loop join against an underlying table which has an index on our function's filter criteria. But in this case, a nested loop join is actually not the most efficient answer to the problem. By rewriting this query into something which isn't quite as nice looking, has fewer apply operators than I would like, We can solve the problem with a single constant scan and a compute scalar versus two constant scans, a filter, a compute scalar, and a nested loop join. But in general, if you only have a select clause in your apply operation, you won't see a nested loop join. In this case, the performance profile is exactly the same as writing a case operation and not using the apply operator. So this is all well and good, but I haven't really given you a chance to see where apply really shines. And to do that, I'm going to show you a query. This query is ripped from the headlines in that it was a simplified form of a real query I had to deal with, not something I made up just for demonstration purposes, sadly. All of the data is fake, of course, but the concepts were real. To take us through this, I'm going to create a temp table called fact. Each row represents one day and contains cost and revenue data for a digital marketing campaign. There is one source of revenue data, so we have the order count, order revenue, and product cost columns. But there are two sources for cost data, source 1 and source 2, each of which has information on the number of times somebody clicked an ad and how much we paid for those ads. There's also a bit flag indicating whether to use source 1 or source 2, as we can't necessarily tell from the data itself. Sometimes we get data for one source, sometimes for the other source, sometimes both, and occasionally neither. So it's all a mess, but we need to sort it out somehow. Now, here's the query itself. We're not really going to marinate in that query too much. It's a long, nasty query which is hard to read. There are is-null functions everywhere, easily 24 of them in this single query. There are duplicated blocks of logic, like case when f.useSource equals 1, then blah blah blah. And the biggest problem of all is that all of these functions obscure what we're really doing here. For example, here is conversion rate. I'll give you 3 seconds without pausing the video to tell me what that code is doing. Just shout it out, I'll hear you. Okay, 3 people got it right, though I think one of you actually worked on that stored procedure, so you don't count. Basically, this code sucks. Let's make it suck a lot less. Step 1. I don't want to see is-null wrapped around everything. I just want to perform these is-null operations once. So how about we put them in a cross-apply block? We'll call that nonull and have each of our input columns in there. Now we can reference nonull.clickSource1 and it performs the is-null check for us each time. Step 2. I don't want to keep copying these case statements. How about I just do it one time? The way that we can do this is to chain apply blocks. I start with my nonull block and then open another cross apply, which checks whether we should use source 1 or source 2 for cost and click information. I'll call that US1, and now we have clicks and cost. This leads to our final product, which you can now see on the screen. By shunting these calculations away into their own apply blocks, we don't have to think about them very much in the select clause, letting us focus more on the actual formulas. Now, when I look at conversion rate, I can easily see what it does. We have a few guard clauses saying that if there are no clicks or orders, the conversion rate is 0. If we have more orders than clicks, the conversion rate is 100%. Otherwise, the conversion rate is the number of orders divided by the number of clicks. This formulation is a whole lot easier to read, and the best part is there is 0 impact on performance. We're doing exactly the same calculations that we would otherwise have done and have the same amount of processing power needed to solve our task, but we're doing these calculations in a way which is a lot easier for a human to understand. And that's an important thing when developing code. And there you have it. So you can probably tell from this video, yeah, I like the apply operator. And anyone who's ever worked with me in the past and has needed to bear the brunt of that fact can attest to this. Apply isn't the only tool that you should have in your T-SQL bag, but it's one which can get you out a very specific set of problems, and for that reason, I think it's well deserving of its own video. If you have any ideas of T-SQL operators you'd like me to dig into for a video, leave those thoughts in the comments section. We'll have links and show notes in the description below. And until we see each other in the next video, take care.